So in question 6, we have to use enthalpies of formation to calculate the delta H, or the enthalpy, for a given reaction. And remember, to find the enthalpy of a reaction, we always take the summation of the enthalpies of formation of the products minus the summation of the enthalpies of formation of the reactants. And remember, you have to multiply these by a coefficient if there's more than one of them. So for this one, we have products right here. So 2 times NO2, and NO2 is given to us as positive 33.2 kilojoules per mole. They're all in kilojoules per mole, so I won't do the units here. Minus the reactants. And the first reactant is 2 times NO, which is positive 90.2. Notice I multiplied it by 2 because there's a 2 right here. Plus oxygen. And oxygen is not listed on here because oxygen is in its elemental form. And remember, any element in its elemental form at 25 degrees Celsius, or standard temperature and pressure, which what this little circle right here means, right here and then right here, is 0. So now we need to do a little math on our calculator. 2 times 33.2 equals minus 2 times 90.2. Enter. We get negative 114 kilojoules per mole for the reaction. Letter B, or the second one. Products, H2O gas. So H2O gas is negative 241.8. There's only one of them. Plus NaCl solid, which is negative 411.2, minus the reactant NaOH solid, which is negative 425.6, plus HCl gas, which is negative 92.3 kilojoules per mole. All right, let's do that on the calculator. Negative 241.8 plus negative 411.2. Enter. So this is negative 653 minus, now let's do this side over here, negative 425.6 plus negative 92.3. Hope I didn't miss my negatives there. There's a negative in front of every single one of these right here. And so that's negative 517.9. Now, this negative minus a negative is going to be a positive. So what I will do is negative 653 plus 517.9, because those two, of course, make a positive sign. And I end up with negative 135.1 kilojoules per mole. There is my enthalpy of reaction for this reaction using the formations in this equation right here. That's number 6.